All right. Hi, I'm Romain Jourdan. I'm leading the Technical Evangelist Group at Riverbed. And today I'm going to talk about application acceleration as a service, right? So, as we saw earlier, our mission is really to bring application and network together and make them performing the best that we can for enterprise customers to adopt new technologies. So the way we do it is that we have many ways. So we had a question earlier about acceleration for IaaS. So if you deploy on AWS or Azure or any other cloud provider, how can I optimize the traffic? So the way, actually, we have that solution. We released that solution in 2012. So since 2012, we are able to optimize all the workload that you have on AWS, Azure, and so on. And the way we do that is that we have a cloud portal which give you access to all the licenses and everything. And from the cloud portal, we are going to spin up an instance in your cloud so to optimize your workload. So end to end, you will be able to optimize that traffic. The main challenge with the cloud is that it's not an L2 network. It's a database. It's a database with pointers to next up. So you can't do a bridging interception as we do today in the physical world. In the cloud, it doesn't work this way. So to do that interception, we are deploying discovery agents on servers. As network guys, we don't like that, right? I mean, it's cool. It's a good solution. But do you manage the service on AWS in Azure? No, probably not. You will have to ask your cloud architects to put that, DevOps engineers, whatever you want to call them, to put that agent on the server. So it's available on Linux, it's available on Windows, whatever. So with this, we are able to redirect the traffic to the cloud. But there's another way. We could deploy it the cloud native way. And for that, we are using, so we have detailed that on GitHub. We have a cookbook and everything available for Azure and AWS, where basically what we are doing now is that we are able to build the interception using UDRs on Azure. So, the pointers, the next up, are called UDRs. So we create some rules on Azure or AWS for that matter to redirect the traffic to our one acceleration stack, which is load balance using native cloud load balancers like the Azure load balancer, and we can stack them as much as we want. And we are using some cloud native mechanism to track the performance and track the availability of our appliances, so to be able to load balance in an effective way. In that way, I don't have to talk to the system guy or cloud architect to deploy agents on the servers. We just need to deploy in my own segment the stack that I want, and I have some Terraform and other scripts to deploy that in the cloud native way. And then I can do my interception. So it can come from, the traffic can come from the internet, it can come from my SD-WAN fabric here with EX, could be something else. And then the traffic goes to my subnet here, which I call transit. So meaning that I have a UDR, so a pointer on Azure here to say that from this subnet or from this subnet to get access to the server, I'm going there, and from there it knows we are making a rule that the next hop is the load balancer, which load balance to the steelhead, and it knows that it goes back to the subnet, to this subnet, and goes to this subnet. So we are adapting our technology to the cloud, and that's the cloud native way. The beauty about it is that whenever there's something wrong about it. So indeed, in the virtual world, in the cloud world, there's no physical bypass as we have. So the way of doing it is to track that all our acceleration stack is working. If not, we're just switching the UDRs. So whenever the traffic needs to go to the client, to the server, we will go straight here, bypassing that time for our scripts to relaunch the new acceleration stack. So does it answer your question about
Yeah. So what about like PaaS and SaaS services?
Thank you. Application performance for SaaS.
I'll be your setup guy all day.
That's perfect.
Are you
going, champ.
interviewing?
So yeah, we know that SaaS might be a challenge, and depending on the scenario, depending on the way you are consuming it, yes, you may have implemented SD-WAN and you go direct to net, but we have many enterprise customers that are still consuming it the old way, which is secure, which is backhauling all the traffic to your original gateway, where you have your internet security stack gateway, and you are doing all the scrubbing and everything. So latency is not that bad, not that good, sorry. So, yeah, but we have also a lot of people that are consuming more and more the app from anywhere. So, if you are traveling, if you are at the airport, if you are at a cafe and you work, you want to get the best performance, but you have no control whatsoever on this network because it's not yours. So, how do you deal with that? So we came up with, last year, we released a product that we called Riverbed SaaS Accelerator, which is a SaaS service. So basically, you subscribe to it, and we deliver the SaaS acceleration for you. So what is it? Is that, so what it gives to you is really good performance in terms of end user experience. Because from my laptop with my still and mobile clients, I'm able to optimize the traffic to Box, to Salesforce, to Workday, to many SaaS apps that we have selected, and we are really giving end user experience benefits here. So those numbers are a mix of download, upload, and also browsing experience that we are getting. So because download is one thing, pushing a file is another thing, but also just the browsing experience to make sure that the app is working very well for my users. So the way we do it is that actually, whenever you want to get the service, you would subscribe to service and you deploy. So you just have to click a button. I'll show you that very quickly, and then we are building this acceleration stack for you near your tenants. So basically, we are going to say, okay, my tenant, my Office 365 tenant, or my Salesforce tenant, or my Workday tenant is in the US, or central US, or in Amsterdam, or in Sydney, and I'm going to create my acceleration stack next to them. And then I'm going to attract that traffic to us. So the agents here, or even our regular appliances, are sending all the traffic that we have identified being Office 365 that we want to optimize. We're sending that to our SaaS Accelerator service, and we are going to optimize that across the network. So we are bypassing Anycast, and we are attracting that to our SaaS acceleration stack, which is for Office 365, which is hosted on Azure and operated by us. So if you are suffering from bad performance because of the network, because of anything, I mean, Office 365 works very well. I mean, it's brilliant what Microsoft did, but the main challenge is the network. And you don't own this network because it's public internet, because it's a cafe or whatever. So we are improving that network performance across the WAN up to Office 365 to deliver the best performance. So very quick demo, it's accelerated. So the first thing that we do, and that's Brendan typing very, very quickly, is actually creating a, oh, that was so quick. Sorry. Brendan is really, really fast. So basically what happens here is that we are deploying the, hey, come on.
Typing speed too.
we are deploying the stack first. So we create the certificates, and here it's too quick because I need time for the rest of my presentation. Here, what's going on here is that we said that we want to optimize Office 365 for 200 users because that's the license I got, and we are setting up this stack for us. So, and the reason why it's accelerated because it takes between 5 minutes to 8 minutes, depending on the cloud, to get the stack up and ready. And to make sure that everyone could benefit from it. And once it's up and ready, this is just a matter of deploying the agents on my laptop or configuring my steelheads so we can optimize that traffic.
And it like auto discovers.
They will auto discover because we have policies, because we are able to use URL to do the discovery, and we have intelligent mechanisms to synchronize all Microsoft Office 365 IP addresses on our appliances. So we have a first packet detection to make sure that we can optimize. That's very quick. It's so fast. Incredible. And so that's what's happening. So we are configuring here very quickly everything. Because it's not really important. What is important is that in a matter of 1 minute by Brendan, you can have all your users benefiting from the optimization for Office 365, and that's great.
So do you have Brandon as a service to go along?
I need to work on
for that.
I need to work on that. Yeah,
$50 million first year.
and of course it's SD1 vendor neutral because we are just using public IP addresses. We are encapsulating everything for us. So the SD1 appliance will see a public IP address, it will direct to net, and there you go. So it can work with everything. So I have only 5 minutes left, even less, to talk about what we are working on. I just wanted to get your feedback on that. So we have been working with enterprise customers about SaaS Accelerator for a while, so they are super happy about the benefit they can get for SharePoint and other apps. But there's a big change related to streaming and collaborative work. So enterprise customers are adopting Microsoft Teams, among others. Microsoft Teams, for example. So we just wanted to share with you what we are working on and getting some feedback on your side. So here I have a great event. I have two awesome guys doing a presentation and over Teams, and we are measuring the impact of on the bandwidth. Okay, so I have one person at the moment, and we see that we have roughly 1.5 meg of throughput for that particular sessions. So what we are going to do now is that we are going to add another client that is going to connect to this live session on the same LAN, and we are going to see the impact on the bandwidth for that particular site. So yeah, that's this IP address. So this one is still working on. And I'm going to add another client. So I'm joining. So that's another client which is still on the same LAN. And what we want to track is the bandwidth utilization on the one side to see the impact of having multiple session, multiple users attending a Microsoft Team event. So I'm adding, so that's app response, that's NPM, and we're going to talk about that later on. But I'm adding some IP addresses, and I want to track the performance. So I'm refreshing the screen, and then we are getting. So here I'm selecting, and we can see that this is my first client, and this is the bandwidth utilized by the new client. So I'm going to add more clients, more people to the Microsoft Teams, still in the same LAN, still in the same environment. Blah, blah, blah. So I'm adding them. This is where I should use Brandon, right? It will be quicker. So I'm adding the IP addresses on app response to report against them. And so 11 and 13, I guess. And blah, blah, blah. And we are going to report the bandwidth utilization. So normally, we should have exactly the same bandwidth utilization for each of the users because they are connected to the same live stream. They are using different clients. So we are using the New Edge, which is based on Chromium. We are using Google Chrome. We are using the default, the native app from Teams. And yes, and we are reporting on the bandwidth utilization here. And I'm going to add more. So everything works. We still have the live event working. And here I'm going to report again to refresh the screen. So, so what is important here to see is that instead of having this connection multiplied by 5, I can see that actually something weird is happening. I can see that that the bandwidth seems to be shared. And I'm not multiplying by the number of users the bandwidth utilization. I'm just kind of load sharing it. And the way we're doing it is that we are able to inject in Microsoft CDN some intelligence. So we will form a peer-to-peer network in the LAN so they can share the bytes.